Let's take a look at the big pink slide here. There's a couple things we can do. At the bottom of the big pink slide, there's some nice deceleration. So we could figure out the deceleration, therefore figure out the coefficient of friction. And then, with the coefficient of friction, we could sort of estimate how much energy we'd lose. But anyway, let's not get ahead of ourselves. So big pink slide, we need a distance reference. So if you have a picture of them at the end there, that fence is 2.37 meters. I'm going to write that down, from one post to another, if you have that framing. Otherwise, you need your own distance reference. Okay, so I'm going to go back here. I'm going to run video analysis. I think I'm going to. Okay. And I'm going to choose a file. And I've got a whole bunch of people slowing down at the end of the big pink slide. So I just stuck them all in this. You can hit play. You can see the people going by, and that's a fairly good one, that first one. That guy stops really suddenly. These guys didn't. And the problem is these are people, so they're moving around. It's kind of hard to... Ooh, that last one is really good. This guy slowing down was really good. Let's find that one. Yeah, I'm going to use that kid. That kid's like a machine. All right. So the first thing I have to do is say that it's 2.37 meters between these posts. You could have your person stand with a distance reference for that if those, if they've somehow changed these fence posts. Okay, but they're probably likely the same posts that were there in 2006 or whenever this was filmed, right? So now I think we're ready. I think every frame is good enough to find the... And what do I do? What do I click on? How about the shoes? Let's click on the shoes. Shoe. Goes behind something. Notice that this guy's slowing down. All right, that's probably enough clicking, right? So I'm just gonna take this and go like this. Okay, now there's two things I can do here. First off, I want to ignore the Y. Okay, there's two things I can do. I could figure out what the velocity is right as they hit the bottom. So I could take maybe those first 4 points and just put a line through them. All right, so choose linear. And there's my velocity. At the bottom of this slide, I'm only going 2 points. So the slope is the velocity right there. At the bottom of the slide, literally, I'm just going 2.651, or this kid is meters per second. And you could compare that using energy, right, to what it should be. Figure out how much energy is lost. Be all scientific about that, right? The other thing we can do is we can find the deceleration of this. Notice that overall this is kind of curved, right? So let's select select this. Let's put a curve on this, and this time let's choose quadratic. Ooh, look at that. That fits pretty well, doesn't it? Okay. And sure enough, it looks like so remember, this is half the acceleration, because our formula, remember, for displacement is x equals 1/2 at squared, right? So the coefficient of t squared is half the acceleration. So it looks like the acceleration is about 1.9 meters per second squared, negative 1.9 meters per second squared. And from that, you can calculate the coefficient of friction of the person as they slide on there. And not all of them are the same. But anyway, so those are some things you can do with the big pink slide.